Hello, class. We're looking at the unit circle picture over here. If you remember, I talked about that. We call it the unit circle because we place it in the Cartesian coordinate plane with our origin here. This is our x-axis, and the circle intersects at 1 unit to the right. The origin is 0, 0, and then the circle intersects at 1 unit to the left at -1. That's the radius is a single unit, and that's why we call this the unit circle. And what I want to do is relate our degrees measure to how the unit circle relates the radians measure. So let's start out by just thinking in degrees briefly here. So this was 0 degrees, and it was also 360 degrees. If we went all the way around once, so we'll label both. This is 30 degrees, 45 degrees, 60 degrees, and we'll stop at 90 degrees in terms of degrees because we're more interested in radians this time. Okay, so what we did say about radians is that 2 pi radians is equal to 360 degrees. So all the way around in terms of radians. So all we need to know is that, and we can start to find the corresponding radian measure to these degree components. So this is also 0 radians, and it's also 2 pi radians, analogous to the 0 and 360 degrees in terms of radians. And then remember, it's radians because we're not placing a degree symbol. So if we know that all the way around is 2 pi, then half of the way around would be what? Well, let's just divide 2 pi by 2. This has to be pi. Okay, so we already know that if I go half the way around, I've gone around by pi radians. Now, 90 degrees is half of the way to pi, so we're going to measure 90 degrees in terms of radians is going to be pi over 2. Not only that, if I take half of the way to pi over 2, I have to multiply pi over 2 by 1/2. That's going to make 45 degrees correspond to pi over 4. And this is 1/3 of the way to 90 degrees, or pi over 2. So if I take 1/3 of pi over 2, I get pi over 6. If I take 2/3 of the way to pi over 2, that's going to be pi over 3. Okay, and now if we continue with this logic here, we're going to get 1 pi over 3. This is 2 pi's over 3, right? So we're going to go ahead and label that as 2 pi over 3 in radians. And if that were corresponding with the degree measure, we mark that as 120 degrees. Okay, and then of course, the third pi over 3 takes us back down to pi. And now I'm going to say that this is 1 pi over 4 to get to 45 degrees. 2 pi over 4 is pi over 2. This is our third pi over 4, our third quarter segment. So that's going to be 3 pi over 4. And then we've got pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. 6 pi over 6 reduces to pi. Okay, so now I know each of these segments, and I can just increase by that amount. So this is 5 pi over 6, 6 pi over 6, which is the same as pi. This is our 7th pi over 6, so we're going to say 7 pi over 6. And then coming here, this is split up into quarters, so we're skipping that one. We'll go back and do that later. So again, 1 pi over 6, 2 pi over 6, which reduces to pi over 3, 3 pi over 6, which reduces to pi over 2, 4 pi over 6 reduces to 2/3 pi, and so on. So this is my 7th pi over 6. And if I take 8 pi over 6, that's going to reduce to, think about it, 4 pi over 3. Okay, so this is 9 pi over 6. So that's going to reduce to 3 pi over 2. Zoom out just a tad. Okay, so that was 9 pi over 6. 10 pi over 6 reduces to 5 pi over 3. And then 11 pi over 6, we can't reduce that. So it's 11 pi over 6. 12 pi over 6 is the same as 2 pi. So we've got each of these labeled, but what I'm missing now is cutting it into quarters. So we know we go up 1 pi over 4 to get to this 45-degree mark, 2 pi over 4, which reduces to pi over 2. So now we need to get to this one. We've got it, 3 pi over 4. 4 pi over 4 is pi. So this one missing is the 5th pi over 4. So we can't reduce 5 pi over 4. 6 pi over 4 reduces to 3 pi over 2, which we already did. 7 pi over 4 does not reduce. So we'll mark it as 7 pi over 4. And now we've got the whole thing sketched out for radians. Now I want to discuss a little bit about what the radians exactly mean again, right? So we created the unit circle, which means it has a distance of 1 here as its radius. And if I take that radius, I take this, think of this as a string. Think of this on the x-axis between 0 and 1. Think of that as a piece of string, and I pick that piece of string up and I place one end of it here, and then I lay the string along the circle as far as it goes. Where the string ends makes 1 radian. But we don't really mark 1 radian, 2 radian, 3 radian. We know that the entire circumference of the circle is 2 pi. And what we really care about is the pi over 6 and all of these components that coincide with the degree measures that we've already taken a look at. Okay, so we also know that 3 pi over 2 is the same angle as 270 degrees. 5 pi over 3 is the same angle as 300 degrees, based on the degree measure if we split it that way. Okay, so that's in essence how I want to start thinking about radian measure. And again, the angle is measured okay, so this angle here can be thought of in 2 ways. As a 30-degree angle or pi over 6 radians. Okay.